So these are the special integral rules as well as integrals of trig functions. And I'm going to show you a process called U substitution or integration by substitution. And so what happens is, much like the derivatives, there's going to be a set of special integrals that don't follow the basic power rule. And one thing to know that the power rule of integration does give the stipulation that n cannot equal -1. Okay. So basically what that means is that your function cannot be, it's not simply taking a simple function, taking the integral of a function of something that's like 1 over, right, an expression, okay? That's a special integral. And so the first of those special integrals will be e to the s, or again, these are all written using this U substitution, just like the derivatives were written using the chain rule. So if I'm taking the integral of e to the ax, my answer is going to be 1 over a e to the ax. Okay, and of course, if this is an indefinite integral, right, you will have that plus c here. Okay. But on the formula sheet, they don't include the plus c. Now what happens if we have a function that is that kind of n to the -1, right? Or your exponent is to the -1. Again, I mean, it's going to give you a function down at the bottom of x plus a. And so the answer to this is just simply the natural log of x plus a, okay? And we'll get into a little bit, we'll do an example where this is involved. And so those are your basic, your kind of your extra trig rules, right? So if I'm taking, or not trig rules, but integral rules. So if I'm taking the integral of e to the x dx, my answer is just e to the x plus c, right? If I'm taking, and these are the most basic of these rules, right? So if I'm taking the integral of 1 over x dx or dx over x, well, that's just simply natural log of x plus c, okay? And so now the trig functions, just remember how the trig functions work, right? The derivative of sine is cosine, and the derivative of cosine is negative sine. So they kind of work in reverse, right? So derivative cosine of ax, again, they're writing, I forgot the dx. So again, they're writing this using this U substitution in mind. Okay, so it's just going to be 1 over a sine of ax. Okay, and again, if I'm just going to do the most basic, which would be if a equals 1, so the integral of cosine x dx, well, that's just going to be sine of x, right, plus c. Okay, and then if I do the integral of sine x, or sine ax, right, dx, well, it's just going to be -1 over a cosine ax. Okay. And again, if I do the most basic one, which would be a is equal to 1, so sine x dx, that's just going to be negative cosine x plus c. Okay. And remember, I know we do trig functions most of the time. The x is a theta. Well, your integral, your variable integration would be x. It'd be theta. Okay. Now, how do we? So we talked about the chain rule and the derivative in the special derivative video. So how do we undo the chain rule? It's something called integration by substitution. Right, so integration by substitution. Well, in most textbooks or calculus teachers, we just call this U substitution. Because what we're going to do is we're going to place substitution. Right, so what we're going to do is we're going to replace one of the functions with the U and then go from there. Okay. Okay, so you're going to need to make the integral look something like this. So we're going to say the integral, okay, and because this is the reverse chain rule, so we're going to do f of g of x, so that composed function, times g prime of x, Okay, so this right here, right, that's kind of our chain rule, right? So we're going to reverse out the chain rule. What we're going to do is we're going to call g of x u, okay, and then g prime of x dx is going to be du, okay? And so what we're really, the formula or the integral ends up becoming f of u du, okay? And then ultimately in the end, so we were going to, the basic steps is say u equals g of x, okay? Then we're going to say du dx is going to equal g prime of x. And then we're going to solve this over here for du, okay? And so we end up with du equals g prime of x dx. Okay, so what we really want to do is we want to keep this g prime of x dx, but so you may end up with a fraction outside, by du. Okay, so let's look at just a bunch of examples and how they work. Okay, so I know this question here can, or this example can be easily solved by, distributing that 2x and then taking the derivative or the integral. But let's use our u substitution, right? And so note that if we say u is x squared plus 1, right, there's our du, right? And so we're going to do, so if I follow my steps, I'm going to say u equals x squared plus 1, du dx is going to be 2x, right? And which makes du equal to 2x dx. And so I can rewrite this integral to be u du, okay? And now I just follow my rules. So it's going to be u squared over 2 plus c, right? We don't necessarily have to put the plus c. And then we bring back in the u, okay? So now I take this u, substitute it back in. Once I now have that final simple integral, now I bring that function back in. So I have x squared plus 1 squared over 2, okay, plus c. So that would be the integral of 2x times x squared plus 1 dx. You could check it using, if I were to, distribute this in, is that what would end up being there? But that's a nicer looking solution than if I would have to do, all that stuff that's, kind of factored out and so forth, or foiled out. Okay. Now, sometimes you run into it with trig. Okay. So what I would say is x squared is u, all right? But notice that if I say x squared is u, right, which makes du dx 2x, which makes du 2x dx. But notice I don't have 2x dx here, but I have 6x. So how can I make this, something times 2x? Well, 6x is 3 times 2x, right? So as I'm rewriting this, I can pull that 3 out, and so then this becomes cosine of x squared times 2x dx. Well, there's my u du, right? So there's u, and then here's my du, okay? So now I can rewrite this as 3 cosine of u du, okay? And now I just follow my rules, right? So 3, the integral of cosine is sine, so sine of u plus c. But now all I have to do now is plug back in my u, which we said was x squared. So 3 sine x squared plus c would be my solution to 6x cosine x squared dx. Okay? All right, so let's keep working some examples, right? So here's one where we have a fraction. So we have x over x squared plus 1 dx, okay? So sometimes it's your numerator that you make your u, but sometimes it's your denominator that you make your u. Okay, so I'm going to say u equals x squared plus 1. Okay, and then I take my du dx. That's going to be 2x. Okay, so I'm taking the derivative of this. And so now I have du equals 2x dx. But note that what's left, it's not 2x dx, but it's x dx. So what do I have to do here, right, to get x dx by itself? Well, I have to divide this all by 2. Okay, so 1/2 du equals x dx. And so now what I do is I take this and substitute in for what I highlighted there, and now I rewrite. So it's going to be, and I can bring out the 1/2, or I can bring out any constant outside of the integral. So it's going to be 1/2 1/u du. Okay, and now this is where we say 1/2, right? Oops, sorry. The integral of 1/u is that natural log, so a natural log of u plus c. And now I just plug in my u. So 1/2 natural log x squared plus 1 plus c. Okay, so that would be the answer to the integral of x over x squared plus 1 dx. Okay, so now, oops, sorry. Let's look at something that looks like this, where we, right, where we don't have, it's not a numerator, it's not a denominator, right? So what we're going to say our u is what's inside the parentheses, right? Typically, that's where your u is, whatever is inside the parentheses. Then we say du dx is equal to 5, right? So 5 dx, okay? And so, oh, sorry. So du dx is 5, right? And so the next step would be to figure out what du is and multiply them by the dx up. So I get 5 dx, okay? But note that what's left over is just simply dx. So I need to get dx by itself and divide by 5. Okay? So that makes dx equal to 1/5 du. So now when I rewrite this function or this integral, I'm going to say 1/5 u to the 7th dx. Okay? And now I can do my 1/5, right, u to the 8th over 8 plus c. Well, 5 times 8 is 40, so it's going to end up being u to the 8th over 40 plus c, and then I substitute in my dx, or my u, which is 5x minus 2, so that becomes 5x minus 2 to the 8th divided by 40 plus c. Okay, and you could do this u substitution with definite integrals, where you're evaluating from a point or from between 2 points, but that is how we do special integrals and trig, especially where we focus on the u substitution.